So about my background, I have studied in Aalto University in Otaniemi, Espoo, and done my master's degree in energy and HVAC technology there, and basically I have worked all my career in building design, doing the energy calculations and then doing mechanical ventilation design. Yeah, so like the natural stack ventilation, it is kind of like it's not a Finnish method, but it's the Nordic countries. So Sweden has it quite a bit. Denmark has it slightly, but it kind of disappears when you go more south than that. So it's about the about the environmental conditions that allow for this kind of ventilation system. So it's not a very global thing, and I think that's also, the book is in Finnish, so let's see if we get some translations at some point, maybe. And then, yeah, so now I'm gonna give a bit of a deeper dive into the regulations side of things and the energy things concerning ventilation and natural stack ventilation. And then when I talk about mechanical ventilation, then it would be the intake and exhaust type of mechanical ventilation, so the modern type. And then the natural ventilation is natural stack ventilation. Here a bit more about the advantages and disadvantages for this type of system. So we have the system is dependent on the weather conditions. So we have to have the temperature difference, and also wind is helping the system to work. But this will cause that it is fluctuating, the working power, the pressure differences are fluctuating, and that means that the user has to adjust the system. But of course that can be also be seen as a benefit, because it has been shown in some studies that when people have the possibility to adjust temperature, for example, they have a knob on the wall that they can adjust, then they also feel more content with the environment, even though the knob would not be connected to anything, and then just have a knob on the wall that they can turn and feel that they have a power. But anyway, in the natural ventilation system, you are actually in power, and you can adjust room by room. You can adjust the airflows, and if you feel that there is too little air, then you just open a vent or open the window in the summertime. Then there's less moving parts, so it's a simple system. There is less noise pollution from the system. The pressure levels are lower in the natural ventilation system, so if we have a mechanical ventilation system, we are talking about 100, 200, even more in bigger systems of pressure in Pascal. In the natural ventilation systems, it's in the summertime it is 1 to 2 Pascal. In the winter time it's 10 to 20. That's about the range. So the pressure levels are very low, so you can't you have to design it. The design has to be precise in a way that you have enough flues and enough vents for the natural ventilation system. You can't just turn the fan power higher. That's not an option. But yeah, and then there's no risk of air contamination. That if the adjustments are done wrong, if somebody closes all the intake air vents, for example, which can happen in certain types of situations, in older, like mechanically ventilated houses where you have only the exhaust ventilation is as mechanical. Then, but in natural ventilation, even if you close all the vents, you will not be able to suck impurities from the structures, through the structures. So the low pressure is a benefit, but also it makes the design more difficult. So all of these, they have like two sides to them. So it's more like yeah, it is a bit of a philosophy question on like where do you want to go with the system choice. So are you kind of more technology dependent? Are you more low tech? Also, natural ventilation doesn't need electricity to work. It generally needs less maintenance, and it has a longer life cycle. Then, like doing a really efficient mechanical ventilation, you can get a better, more precise air quality. You can get higher energy efficiency if you do it right. This is the definition of natural ventilation concerning the building regulations in Finland. So this is the natural stack ventilation. So it's height difference and partly also wind driven, but mostly it is the height and temperature difference that we are dealing with. We had a new building regulations which came 2018. They came into force, and in that round of changing the regulations, they took natural stack ventilation again into the regulations as an option. The regulations was basically just for mechanical ventilation. It was not really mentioned there, and not really regarded as an option. And then also the energy regulations, they were becoming, every time they were updated, they were becoming more tight. So at some point for natural ventilation, the situation became that it was still possible in theory, but in practice basically all of the designers had already decided that it's not worth it, because there is so much like other design choices that you have to kind of tighten, or like make thicker walls, have better windows, all kind of more expensive stuff that you have to do if you want to have the natural ventilation system. And then also the building inspections pretty much were against natural ventilation, because the energy efficiency subject was so much on paper then that it was regarded a bit like heresy to suggest this kind of natural ventilation, which wouldn't have the possibility for heat recovery. But then this was pretty much a political decision that they then took it again as an option, and also actually gave an exception from parts of the energy regulations. So here it's the fulfilling the heat losses limit, vertailulämpöhäviön laskenta. it's an Excel spreadsheet that the energy expert has to calculate, and then in there the ventilation heat recovery is taken into account. But nowadays for natural ventilation the requirement for heat recovery is 0%, whereas for for mechanical it's 55%. So that's a big difference. Even though for the energy certificate we still have the same limit. So basically the houses with natural ventilation, they can't use any more energy than the houses with mechanical ventilation, but you have to use other means. But this one calculation was many times like yeah, it was a big issue, even though it doesn't it's not the full picture about the energy efficiency even. Yeah, so for new buildings the situation is nowadays much better, and also the treatment from the building inspections, it has changed in the last 5 years. I have been working quite intensely with natural stack ventilation from about 2016, and during that time how it's regarded in the building inspection offices, it has changed quite drastically. So nowadays they do take it like the designers, many times the designer still has to show like in calculations a bit more than would be required for a mechanical ventilation, but it is not like from the beginning that they will say no to the option. As we are in Arkkitehtuurikeskus, in the municipalities that are more on the countryside, these things are much more simpler. So nowadays, when the kind of like the mentality has shifted, so in a municipality on the countryside nowadays there is no problem, and even the plans can be about the same quality as for mechanical ventilation, natural ventilation, mechanical ventilation. They are treated the same. So if you have a good-looking plan and you have the flues there in the right places, that's okay. You don't have to even show any calculations. In the cities, it's more difficult still for natural ventilation. But on the countryside, the situation is already very good. There has been also some issues that in some cases building inspections have because of the energy regulations for renovations. They have even sometimes decided that you have to update your whole ventilation system. That was pretty much like in the beginning when the new regulations came in force, but then that hasn't been the intention from the Ministry of Environment to begin with these regulations, and they have many times now said and corrected that if you are maintaining or repairing this natural ventilation system, it is not a requirement to put in heat recovery. So you can basically indefinitely you can upkeep your ventilation system in the form that it is. And then we have some studies have been made about like follow-up studies on existing buildings in Finland. So I will tell a bit about these results and talk a bit more in depth about this energy efficiency issues. So this is one big study that has followed up about 100 single-family homes, and they were measuring. This is from Tampere University, And they were measuring many things from these houses. They were all of the houses were already in use, so the residences were using them as normal. They went there and measured, for example, the air exchange rates in these buildings. In the winter time, they did these measurements, and they didn't make any changes. So if the ventilation was low, it was low. They didn't make any changes to the habits of the inhabitants. And it turns out that the ventilation rates that they used in naturally ventilated houses were 25% lower in the winter time than the ones for mechanical ventilation. And yeah, this was a study where there is no, like, they didn't find a correlation that naturally ventilated houses would be higher consuming than the mechanical ventilation houses, and there was no like strong correlation with the type of ventilation system and the energy consumption. But there's of course like a lot of factors that play into this. The ventilation energy consumption is only about 20% of the whole. So and then the study conclusion was that the living habits of the inhabitants is definitely the highest influencer in the results of the energy use of the houses. But the lower air exchange rates are partly due to the like natural regulation of ventilation rates in these types of systems. So when you take the air through the vents directly into the room, and it comes at the temperature that is outside. So if there is cold air coming in, then people will notice cold draft when the airflows are large, and they will usually then go and close the vents at least slightly, so that there's less air coming in. And in the Finnish climate, this will lead to even better air quality because of this, like the humidity factor that Julia was already referring to before. So, of course, it's not good if people go and completely close the air vents. But if people know the system and know how to use it, they will not do that. They will just slightly close them and adjust it according to the weather outside.
Sorry, I have a quick question. In the study, was indoor climate quality assessed or measured in a way as well? Or will we speak about it? Or did it just concern the energy consumption? In terms of, yes, in winter there was a lower air rate, so people would close the air vents more, but would that cause some people to feel that, okay, I'm doing this because of the draft, and maybe they felt that the air quality would have lowered from that? Or was this an aspect in that study too? Or was it only energy consumption?
Yeah, I do think it is quite an extensive study. And yeah, I don't think that this has a very big effect on the air exchange rates. Still in those houses, they are quite close to the levels that the regulation also requires. So it's not a drastic decrease in air exchange. But now I don't remember directly, like, if the people were asked about the feeling of air quality. So that's. But you can also go through the study and check, because there is quite a lot of data, and they have really measured many things about the houses. So it's a very interesting study to go through for like a practical, yeah, actually like houses that are lived in and in practice.
I have a question. The energy consumption is about this ventilation mechanism, or is it also the heating system included there? Like if you have the open vents, you get the cold air in, and then you want to heat the room, then the temperatures go down, and you have to put on more heat.
Yes.
Is this also included in that study? Like,
yes, yes, they have in this in the study. They took the total energy consumptions and they were comparing those.
Okay.
So it is actually including all the energy consumption. So the heating system, also energy consumption of the like electricity consumption of the fans, but also of the appliances. Like everything is there.
Okay.
And it's not really separated out either. So it is like clumped in. So energy consumption is energy consumption, and it's like what is the effect of the ventilation specifically. You can't really make it out from the study, but it shows that these houses that do have the natural ventilation, they are not, at least they're not kind of standing out from the data that they would be worse than the general houses.
I was reading an article about this research when it was being done, and at that time they were saying that the naturally ventilated houses had smaller energy consumptions than the mechanically ventilated houses, and when comparing the mechanically ventilated houses, heat recovery made no difference. So of course they were expecting that in the houses with heat recovery, the energy consumptions would be lowest, but it wasn't at that time. But of course the research is somewhat old, from 2005, and heat recovery units have gotten a lot better, so we would need new studies.
Yeah, but also the problem with the data is that they haven't looked at same kind of houses. So the houses are all types of houses basically. So if you take a natural ventilation house and you take a mechanical ventilation house, they will not be identical houses. So basically you can't like make a specific conclusion, but in general that was the houses with natural ventilation were actually quite energy efficient, but there's many other factors that play into that data. So, but at least we can say that they were not like they were not the higher consumers, the naturally ventilated houses. So it's not a big factor in the energy consumption there. And yeah, so continuing on this, why I say that the air quality might be even better with smaller airflows, that's kind of counterintuitive, but this is talking about the Finnish climate in the winter time and the comfort, also relating to relative humidity in the indoor air. And basically when it gets colder outside, the outside air is drier, and when you take it in and heat it up, it gets the moisture stays the same, but with the heating, the relative humidity goes down. So in these, we can see that the lower levels of ventilation rate actually give a climate which is more comfortable for people. So the perceived temperature comfort is better here with 4 liters per person than at the really high 12 liters per person. So that's one impact of the ventilation. When we talk about energy efficiency, it's winter time is the time that we talk about. So actually taking down the ventilation rates in the winter time makes a lot of sense for well-being of people. and for energy efficiency. And then when we do that, the effect, the gain that we can get with the heat recovery ventilation becomes smaller. So this is one factor that is kind of in favor of using natural ventilation also. And yeah, then there's another study done in Finland about performance of people in office environments, and how there was also a lot of stuff in that study, but they were also studying the effect of air or ventilation rates. And the conclusion was that having very low or very high air exchange rates was not having a big impact on the performance or the comfort, perceived comfort of the people working at that office. But the important factor was that they had a cooling and heating system for the office, and they were able to manage the temperature in the space. So even with the low ventilation rates, the temperature were not allowed to rise. The temperature was the same for both of these cases. They were looking for general comfort of people and how they were doing in some tasks that they were given, and then they were comparing these ventilation rate cases. And actually, I think there is now there is a discussion about these ventilation rates. Now in Finland we have like 6 liters per person is the norm that is in building regulations that you have to have. And then but there's talk about lowering these rates now. I think in like the Europe REHVA, I think it's called, the European HVAC Association, and at that level they are considering if they should actually take down these recommended rates for people. Let's see what happens with that. But in the winter time, like if we don't talk about regulations, we talk about general use of residential houses, then like taking down the airflow slightly in the winter time is generally a good idea in the cold climates. The point is that in the energy certificate calculations that we do in Finland for houses, these practical considerations like taking airflows down in the winter time, they are not taken into account. The airflows are always taken as constant all year round, and at the higher level, even a bit higher than would be like nowadays the requirement of the building regulations. And then there's some other factors, like in natural ventilation we have the easy possibility of taking down the air exchange rates in those rooms which are not in use. So if there's like an extra bedroom in the house, you can actually have the vents really small in that space without affecting the house otherwise. In the mechanical ventilation case, that's normally not possible at all. You just have one speed adjustment for the machine, and then it will affect like all the spaces in the house. So this kind of adjustment possibility is helping with the energy efficiency also. Yeah, and in practice, how these things will affect the energy efficiency. This is like an output from calculations that I've done using the same method that is used for the energy certificates. And this is only taking into account the heating requirements for the ventilation air and also the electricity consumption of the fans of the ventilation machine. On the right side here is the case with the calculation parameters that would be used for normal energy certificate. And there we can see that like all these green spots, so from heat recovery efficiency from 85 to 55%, and then the electricity consumption of the fans. So there is like a these red ones are the minimum requirement of the regulations, and then we can go better, of course, with both. So counting this way, it shows that the mechanical ventilation with heat recovery is better. It is more energy efficient. But if we take into account that the airflows in the natural ventilation system will be actually adjusted with the weather, with the season, yeah, then the result looks quite different. So in this case, like a average mechanical ventilation system would consume about the same if you count the electricity consumption and the heat consumption. And then we can go like with a passive house design, so we do a very high efficiency for both the electricity use and the heat recovery efficiency. Then we can go better than the natural ventilation, but we can also do like a cheap house with just barely fulfilling the regulations, and then we're actually doing worse than for the natural ventilation case. Yeah, and one important part of this calculations is that we assume that we are using like a modern heating system with quite an efficient ground source heat pump, which is nowadays pretty much becoming the norm in Finland for new build single family homes. So taking into account that factor and the like the practical use of these ventilation systems, then like doing a natural ventilation system is not really a crime, considering like this energy efficiency side of things. Some like flue possibilities, some flue structures. So this is the old style with brick. And then we have from Schiedel, nowadays we have this light concrete precast like element flues. They are actually designed for natural ventilation specifically. They have the ones for fireplaces, but they also have a product for natural ventilation. This is this is their use in practice in a renovation. And here is another case with that product. And then there's also some other types of these ones. This is basically the same brick material, but in a different form factor. I have had one project where this product was used, but it's not. This is not even usually available in Finland, but Wienerberger ordered it from Denmark, or I don't remember exactly. They were able to get it. Then some modern products for vents, which are taken from the old style and redesigned. Also with better insulation, and then this is like completely the old style, but just as a new product. Some of these are for mechanical also, so this is like a intake air fan, which is not actually taking air in so much as to recirculating air. So room air is recirculated to heat the incoming cold air. So you get better conditions in the room without cold draft, even if you take cold air in through the walls. And then this product is nowadays very popular in Finland. So it has a thermostat. So when it's cold, the vent will close automatically to a smaller opening, and then it will open when it's warm. So in natural ventilation, it's very good because people don't have to adjust the ventilation so much. It kind of does it automatically. And it's still quite low tech. There is no electricity, just a regular thermostat. And then these are just very simple, like vents for natural ventilation, for the exhaust. And then, yeah, so there's the jonnehattu, jonnari style, and there's the rotor style of wind cowls, yes. Yeah. And then just a small mention of Domus Classic that is selling also these products because they helped us to get the second round of publications. What's that? Second edition of the book out. They actually took the risk and decided that it's worth selling. So.